This is the completed work, but the general process is just to add photos and then process them. To process the photos, you add them, align them, you build the model, build the texture, and after building a texture, or rather before building a texture, you crop out any background, then you build the texture. This is the finished model, both bottom and top. The tools I hovered over were for cropping out background and artifacts. This is me rotating the 3D model. And you get to produce the 3D model from two separate chunks, top and bottom views. You use align and merge chunks. And for the sake of illustration, we will then open a new file where we will align and merge chunks ourselves. For now, this part of the video is just showing off what the finished product looks like and the different chunks or tools used in the process. These are the files used in creating the 3D model in Agisoft Metashape. What we're going to do is open an already made portion of the object, the bottom view. Then we're going to append or add another chunk, which is going to be the top view. And we're going to record up until the alignment process. There will be a cut in the video where we will then skip to the merging process. But before we merge, we will show off some tools that we use to align the chunks before we merge them. This is the merging part of the process, but before you merge, you need to align the chunks. So what you're going to do is you're going to align the chunks, and usually they should be point-based or marker-based, but my camera does not have coordinates, so I cannot do marker-based, and point-based does not create perfect alignments at all times. So what we did in this process, me and my partner, we manually aligned the chunks using the transform function that can be found under the model tab. If you click transform, it has the option to make the chosen chunk object move. You can rotate it, you can also scale it. The following video will show roughly what we did in making the 3D object by manually aligning it, and then once it was sufficiently aligned, we merged it. In this part of the lab work, we have already created the program to interface with the Arduino Uno. For the sake of illustration, we will be doing again roughly the process to make this program. This program will control an LED light, but the button to turn it on and off is built into the LabVIEW control panel, and there is also an indicator light that is red for off and green for on to help us know whether or not the LED is working based on our input. We create a while loop structure, and then we put in the different icons, open and close. We link their inputs and outputs, and then we create their needed constants and controls. We link to the digital write also constant, and we link to it. And then when I say we link to it, we use the create function from the Makers Hub toolkit, links, as it's also known. We link to the digital write constant. That's where we put our digital pin, and we also link an indicator where we will also link later the LED light that we will make by putting a boolean in the control panel into the right side, and we'll also be replacing what we initially put in the digital write with a push button. What that means is in the initial steps, the indicator or was it control that you will link to the digital write, it will come out as a green LED circle which you replace with a push button. And then the last step, although not shown here, is to create a decorated bevel for all the buttons and then to push it to the back. And the video that will follow will be an in-person video of the program and Arduino board working. Before showing the working of the program and the Arduino board together, first we have to link using links the program to the Arduino board by using its firmware wizard. We select the right choices depending on the prompt that arrives, and we click next. After making our choices, this will upload the link's firmware, and in the next video it will link the COM port to the Arduino. It will link the Arduino to the COM port, and then it will allow the program to run. Here we see that the COM port is at COM port 6, the Arduino is linked, and the program is running. That's all. Thank you.